Okay. Um, so that's just where, again, they give you talk about the sample spaces and all the different things that are there with that. After that, they go through and give you all the options for those. Now, they're still going to also bring in the fact that the intersections and the unions and the complements, all those things will still be things that they'll bring in for this one. So when they go through these, they'll also talk about with the sample spaces that you have here, they'll also bring in all the different parts that we were looking at back in section 2. So they kind of spin off of that one. So I think the very first thing that they will talk about here is disjoint, where they give you something else to talk about with these. Some a little bit of new vocabulary here, but disjoint events basically is that if they're disjoint, they cannot happen at the same time. And when they talk about disjoint and how that those are sometimes shown when they go through this, they may say that E and F are disjoint. And the notation they would have with something like that would be that basically this the intersection of E and F, since they're disjoint, they're not going to happen. There is no overlap on that one. Basically, they're just going to say that that would the intersection of E and F would be the empty set. Okay, and then on the flip side of that one, you could also say, since we talk about the complement, if you talk about the intersection of E and E complement, that would also be disjoint or the empty set. Okay, and then they'll give you some examples of what those two things would be. They'll give you two sets and say, okay, are these two things disjoint? And sometimes it's some of the examples are a little bit weird for some of these. That they'll give you just some different ones that have something like this. I know one of them says wearing a hat and glasses. Though, and this is some examples I saw when I went through and checking some of these. Is that disjoint or not? So that's one of those that you definitely can wear a hat and glasses at the same time. So this would be one of those where you'd say that it's not disjoint. So and from what I can tell, they don't give you any that's really mathematically based. They're all different things like that. It's like driving a car and swimming underwater. They always give you two things that's really something that you can do. It's really obvious on what the answers are going to be for those. So they'll give you the setup for those when you go through all the parts about what's disjoint or not. And really what it comes down to is when it starts doing that, they're building up to all the probability parts of it. So the first thing they back up and do, they talk about just your basic probability. And for that one, they're going to say that your P would be your probability. And So the probability of some event happening is going to be the number of times that event occurs, or the number of the event occurring, over the number of the sample space. Okay, and again, this is all just basic probability for anything that you're doing. So it may be something where, what's the probability of getting a 2 when rolling 1 die? Well, there's only 1 2 on there, so your basic probability would be 1 out of 6. You know, if it was a probability of getting an even number, well, there's 3 of them. You know, it's half even, half odd, so you've got 3 out of 6, which would simplify down to a half. And they're going to ask you on all these problems that you go through when you do the probability, they're going to ask you to simplify every possible one that you could go through this. And if you're not a card player, they do a lot with cards with these. They do a lot with dice when they talk about the probabilities. So it may be, what's the probability of getting a red ace from a standard deck of cards? Well, there's four aces in a deck. There's 52 decks, or sorry, 52 cards in the deck. And there's 4 of each, 4 aces, 4 twos, 4 of those. And of those, 2 are red and 2 are black. So your basic probability is that would be 2 out of 52. But then you have to simplify it down to make it 1 over 26. Okay, so they'll give you different scenarios, talk about the different things, the different outcomes you can get with those. And again, as long as it's basic probability, they're not making you think too far or too hard outside of what it would normally be. If it's a problem where if it's something you don't understand in the homework, of course, you can click on it and just understand that, okay, that's what they were talking about. But a lot of what they're going to do is they're going to be, flipping a coin where you get heads or tails. You're going to be rolling a 6-sided die, or maybe it's 8-sided or 12-sided. They give you how many sides it would be, and then you just figure out whatever the events would be from that one. That would happen. And then with that one, they also give you some of the basics that go with this one, is that the sum of all probabilities and again, if we're talking about one specific thing that we're doing, if we're talking about a deck of cards, if you talked about all the probabilities of something happening, you put it all together, the sum of all probabilities of all the events of that event, of that set happening, is, and they're not going to talk about it in percentages. Most time that's where you would say that's 100%. This is where you're going to, if you were doing 1 out of 26, you have to change that to a decimal. Let's see, what would that decimal be? It'd be like 0.038 if they ask you to convert these to decimals. And with a lot of the decimals that they do in this case, they'll ask you to go to 3 decimal places. That if you went through, the deck and talked about everything that's here, if you add all this together, the sum of all the probability of every single event happening would be 100%, but they're going to put that as a decimal, which means it's going to add up to be 1. And if you talk about each event of whatever set it is that you're talking about, each event will have a probability that it could be that it doesn't happen at all. So that one you would start at 0, being, it's not going to happen. That's like the disjoint set. It's an empty set. There's no way it's going to happen. It's not even possible. And then it could also go up to 1, because that would be 100% chance of something happening. Okay, so each end of, and again, that's talking about, if you put all the possibilities together of every single card in there, it should add up to 1, which would be the same thing as 100%, but each individual one is going to be as low as 0 of it not happening, or it could be that it'd be up to possibly getting a 1, that it definitely will happen for that one. If I ask you for what's the probability of getting a green 2, well, there's no green card, so that would put you at 0. If you want to get an easy one for 1, that would be one where they could ask you what's the probability of getting a red or a black card. Well, that would be 100%. That would be a 1, because every card in the deck is either black or red. Okay. And they'll just, same thing with this one. They give you some basic probabilities, have you work through these, and just getting some of the numbers. A lot of it is just being careful with the wording that they give to you on these. A lot of times they're going to have it so that it talks about something is no more than, or something is less than. I think that's the biggest thing you have to remember, is that if it's something, let's say we're talking about still rolling a die in this case. And they like to tell you on these questions, when they talk about the die, they'll tell you that it's one single fair die. It's not using some loaded dice when it comes off of it. And they may tell you that what's the probability of getting a number less than 4. Well, less than 4, that's 1, 2, or 3. So that's 3 out of the 6. So that would be half. If you're going through those. Where you have to be a little bit careful is if they do, and I don't think they'll do this a lot, probability of getting a number no greater than 2. So when I start putting the no in there, that's when you have to kind of stop and think about what they're doing. This one, if it's a number less than 4, it's pretty straightforward. If it's no greater than 2, which means it's not greater than 2, so if it's not greater, that means it could be less than or equal to 2. So if it's less than or equal to, that could be a 1 or a 2. So that would be 2 out of 6, which would be 1/3. Okay, so to me, that's the ones you have to be a little bit careful of, is that if it says something is no greater, if it's just straight less than or greater than, those are really not anything to worry about. It's when they start giving you the no greater than, or it's not less than, that's when you have to kind of read through that one and say, all right, well, if it's not greater, that means that number could be less than, or it could be equal to. And then that's why you're running through the different sets of numbers that you're going through there. That's about the hardest thing I think that they'll throw at you, just getting used to those. Okay. And I think for 8.3, I think that was pretty much about it. It was pretty much just your basics when it comes down to everything that was happening in your probabilities. They do give you some charts to kind of read through, but those charts are usually pretty easy. That they'll give you, just one event of some things happening. And I know I'm going to share this one to you real quick because this was something from the book. I know they do something like this where they give you some probabilities of some things here, and they'll ask you, all right, is this possible? Is this probable of any kind of outcome of something happening up here? As soon as you see the negative number here that's on this last event, S5, that's one that would not be something that would happen. So they would say, all right, tell me if this thing is possible or not. Well, that case, you would say this one's not because you cannot get a negative probability there. Sometimes like this one, if you look at one of these examples, it's here. Everything here is between 0 and 1, so they're good. And just go back and check, and as long as all this adds up to 1, then that would be one that would be good there. I'm not sure. Let me check that one real quick. We got 0.09 plus 0.32 plus 0.21. Yeah. So if we were looking at 47 right here, maybe a little hard to see on that one. But if you take all the numbers that's here, all the probabilities, add these up, it does come out to be 1. So this would be one where they'd ask you, is this possible or not? And this would be one you would say, yes, it's possible because all the probabilities add up to be 1. Yeah, so, that's kind of what they're looking at. Some of the charts they may give to you may be just something like this where that they've got, a list of people that's here, all the different, they've asked a survey. All you've got to do then is just add all this total together, figure out what the total would be. And if they ask you, all right, what's the probability of somebody strongly agreeing, it'd be 110 over whatever the total would be. That's one where they would tell you to convert that number to 3 decimal places or something like that. Okay, so with 8.3, that's pretty much, they don't get too far in depth with everything. It's a basic probability, so they don't get really too in depth. I think, again, the hardest thing sometimes is going through and talking about whether something is no more than or no less than. I think everything else would be pretty straightforward when it comes off of what it is that you're going to ask for you. All right. And 8.4, they do more with probability. Keep working on doing some more basic concepts on this one. But the very first thing that they do they call it the addition rule for probability. Is basically this. So we'll do this. So we're going to say the P of E union F is P of E plus P of F minus P intersection of E and F. And you may be going, well, that's the same as that's basically the same as the counting rule that we did back in 8.2. And it is. They just tweaked it a little bit. So it's basically the same rule from 8.2. So it's really not anything new. The only thing that they do with this when they say, all right, well, if we put it into words, and it's still the same thing we were doing earlier, is that if you do the probability of E or F, still the probability of E plus the probability of F minus the probability of P of E and F. So it's still the exact same thing. They just talk about what would happen there. All right. And the one thing they add in, which really you don't really have to have it, is they talk about disjoint events. Well, with disjoint events, there is no intersection that you have at the end for this one. So for that one, the probability of E union F is just P of E plus P of F, because there's no, they're disjoint. That means there's not going to be any overlap, so you don't have to worry about this part at the end. So it's just that front part of the addition row that you have back there. Okay, so for the complement rule, and there's actually two different ones here you can spin of either way. The probability of getting the complement of whatever event it is that you're talking about is 1 minus the probability of getting that event. You also could flip that one around and say, well, the probability of getting event would be 1 minus the probability of the complement of that event. Okay, so that's all the different probabilities of different things. And then the back part of section 4, and we'll go ahead and talk about these because this is the formulas you would have here, is they go from talking about probability to talking about odds. And there's really only two of these that they're going to talk about. Is that you have the odds of, this is where if you ever read, the back of a M&M's pack or of, Snickers or Dorito, whatever, if they're giving away something, they always talk about the odds of winning. That, the odds in favor of you winning something, it's always, 1 in a million. But usually it's not going to be 1 in a million. It's going to be 1 in 999,999. So there's going to be a million bags that they've printed off and sent out, and one of those is going to be the winner. So it's always, when they talk about the odds in favor of an event, E that we're talking about. Then it's the probability of the event happening, the one winner that you have. And then all the people that aren't going to win, all the losers. So there's, if they print off a million bags, then there's one winner, there's 999,999 losers in that one. So there'd be 1 out of 999. And a lot of times they'll write it like this, but most of the time they'll write it more like this, that they'll give you the probability of the event, and then they'll say 2, probability of the event like that. Or sometimes they'll put a colon in the middle. So it could be a fraction. It could be where they actually use the word 2, or it could be that they put a colon in there to show them when they talk about odds. Okay, and then flipping that one around. They say, well, if the odds of an event happening are M to N, it's 1 to 999,000, whatever the case would be there, then the probability of the event would then be taking whatever you have for M, the chances of you winning, and then on the bottom you're going to add those two events together. Right. And if you want to talk about the complement of something like that happening, well, then you basically just reverse the order. So that would be n over n plus n. Right. And everything in section 4, they're going to go back to one of these different, if you want to call it a formula, different rules that you have for these. And they're going to have you just go back and work through the different parts of these, whether you're taking something that's, where it talks about the odds of something and you've got to tell me what the probability is, or they just say, here's some events happening, tell me what the probability is going to be. So they're going to come back to one of these. This is like your rule sheet for 8.4. And every problem that they're going to ask you is they're going to come back to one of these rules and have you work some problems out to figure out, what the possibility could be when you go through those. All right, and what we'll do for the rest of this is we'll just go through some examples of all the different options that they'll throw at you. Okay, so the very first one they give to you in section 4, I think it should be something similar to this, that they're going to give you a pair of dice as rolled. And then they're going to ask you, okay, find the probability of, and then they'll give you 3 or 4 different options of things to do for this one. Find the probability of the sum is not more than 4. Okay, so if you didn't see a lot of the not more thans and no less thans in section 3, section 4 is where they're going to bring those out a little bit more. Okay, now here's where you have to go through this one. And the first thought I had on this one, and again, this is where you have to kind of slow down a little bit and think that we're talking statistics and probability on these. More probability is that it's not just, okay, I'm going to roll 2 dice, I'm going to get, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, because that's the first thought that we'll have. So if the sum is not more than 4, that means that the sum is going to be less than or equal to, well, if it's not more than 4, it means it could be less than or equal to 4. So that means then the sum could be, 2, 3, or 4. And this is one of those, if you don't slow down for this one, is you'll think, okay, well, there's 3 numbers, the sum can be 2 through 12, so that would be 3 out of 11, and we'd go from that one. This is one that you almost, and to be honest with you, this is one where you really want to go ahead and make a chart on this one, because there's the 36 different outcomes, or you just may want to do a Google search on it so that you've got all the different possibilities, because this would be one that, you've got to go back through and say, all right, well, the sum could be, for roll 2 dice with the lowest outcome, that's 1 plus 1, so that's 2. All right, if I want the sum to be 3, it could be 1, 2, or it could be 2, 1. If you want the sum to be 4, it could be 1, 3, it could be 2, 2, or it could be 3, 1. So this is one where you almost have to go through and list every single, all the different outcomes you've got for these. You want to go back through and list every single pair on this one, because you got to take in consideration that all those different things could happen here. Okay, for 5, it could be that it's 1, 4, could be 2, 3, could be 3, 2, could be 4, 1. You might even put just how many outcomes that would be at the end of it. There's a 1 here, there's 2 here. There's 3 here. And it does have a pattern when you go through these. It could be 1, 5, could be 2, 4, could be 3, 3, could be 4, 2, and it could be 5, 1. So we get a sum of 6. There's 1, 2, 3, 4, 5 different outcomes. 5 different ways you can get a total of 6 in this one. And if your sum is 7, this would be your max that you get, because it'd be 1, 6, 2, 5, 3, 4, 4, 3, 5, 2, or 6, 1. So you've got 6 different ways you can get a 7. And then after that, it should basically be the mirror image on this one. If you're talking about 8, there should be 5 different ways to get an 8. If you do 9, there's 4 different ways. If your sum is 10, there's 3 different ways. If you get to 11, there's 2 different ways. And if you do a sum of 12, there would only be 1 different way. All right, and again, if you go back through and add up all these different outcomes on this one, that means there's 36 different total outcomes that you can get from this one. All right, and if you haven't, I would say, just because the DICE questions, that tends to pop up quite a lot when you're going through some of these questions in section 4. So if you haven't already, just go ahead and kind of set this off to the side, because you'll want to come back to this one, because they'll keep reusing this part of it. Okay, so going back to question 1 then, it says, all right, what's the chances of getting something that's less than, or not more than 4? So that means it's 2, 3, or 4. Well, if you do that, there's 6 different outcomes you have here. So that would be 6 out of 36. So it's going to make it 1 out of 6. All right, so is everybody okay with that one? Because I know that was one that, if you don't slow, this is one of those problems that if you don't slow down on this one, a lot of people just go, oh, well, if it's not more than 4, it could be less than or equal to 4. So then it's 2, 3, or 4, and they start figuring out, okay, well, there's only, 11 different ways you can get numbers from 2 through 12. So then it'd be 3 out of 11. Well, no, this is one you've got to consider that, 1, 2 is different than 2, 1. So you've got to go back through and think about every single outcome you can get for those. And I think once you do that, then the problems actually aren't bad at all. I mean, I'm going to it. So, everybody okay there? Anybody got any questions on that part? All right, so for B, let's say that the sum is not less than 7. Okay, so if it's not less than 7, that means the sum could be greater than or equal to 7. So it means it could be a 7, could be 8, could be 9, could be 10, could be 11, or it could be 12. Okay, so then that's basically saying, all right, that's our sum that we're looking for from 7 through 12. We need all these outcomes from 6 down to 1. So if you start adding those up, that's 7, there's 7, there's 7 there. If you add all those outcomes together, that's 21 out of 36. And if you simplify that down, that would be 7 out of 12. Okay, and then one where they don't use the no more than or no less than or any of those is this is one where they're going to say the sum is between 3 and 8 exclusive, which means, okay, 3 and 8 are the it has to be between 3 and 8 and exclusively between that. So that really means it's going to be 4, 5, 6, or 7 is what they're saying. Okay, and then we're back to the chart over here. So if the sum has to be 4, 5, 6, or 7, there's our sums at 4, 5, 6, 7. We're adding up 3, 4, 5, and 6. So that is 9 and 9. So that would be 18 possible outcomes out of 36, which would simplify down to be a half. Okay, so just keep that chart in somewhere close by. Keep one that's kind of laid out, or if you got one, if you got it saved, you can look it up, do a Google search, and find those same things as well. But just keep that close by, because a lot of the problems that they do with dice, they'll always come back to this one where you're finding the sum of 2 dice. So you're always going to come back to this type of thing here. And if you're one of those people that you need to fill out the chart to finish this one off, and some of you aren't, so that's okay. This would have to be 3, 6, 4, 5, 5, 4, 6, 3. To get 10, 4, 6. Okay, so if you need the full complete chart, that would be your full complete chart there. Okay, so just hang on to that one, because again, that one, it's going to come back to in section 4. When we get to section 5, I think it comes back to it again in section 5. So that's one of those, just kind of hang on to it, because it'll keep coming back to it a lot when we go through everything here. Okay, so if you want to take a quick break, I need to take just a couple minutes here. All right, so we're going to take this chart and put it away, and we may come back to it here in a minute. But those that some of the problems, when I was looking over some of the problems they would ask you, that's one of those that had to make a little chart out, because you had to keep coming back to it for all the problems that they would keep asking you. Okay, so they'll give you some different options, some different upper probabilities. This would be one that would be similar to number 3 in the homework. This is one where they're going to talk about some Venn diagram stuff again, going back to some sections we were doing earlier. This time only having 2 events. So probability of Z and Y. Okay, so they would start you off with this. Probability of Z is 0.41. Probability of Y is 0.35. And then the probability of Z intersection Y would be 0.17. All right, so very first thing that, to me, that I would do is I'd go back in and start filling this thing in. We'll make the circles a little bit bigger. Okay, so there's Z and Y. The intersection here is 0.17, so that would put that 0.17 in the middle. And to find everything else, that's where, okay, so the intersection is 0.17. Everything in y is 0.35, so we would just subtract these two numbers to figure out that then y would be 0.18. Okay, do the same thing to get z. Subtract these two numbers, since this is the intersection, subtract those two numbers to figure out then that would be 0.24 for z. All right, and then some of the other, and they're going to ask you all kinds of different questions. So once they've given you that part, I think the extra thing you would want to kind of do then past that is that since you were given this, go ahead and start getting the complements. The complement of z would just be subtracting this from 1. So that would be 0.59 for z complement. Same thing for the complement of y. Do 1 minus 0.35 and get that would be 0.65. And then you can also go back to that probability rule that we had back here that we were doing, that was the E's and F's. Same thing that we were doing back in section 2. Said that if you want to get the probability of z union y, well, that's the probability of z plus the probability of y minus the probability of the intersection of those two. You may not need it, but that's one of those things that's kind of good to have it there, just in case they go through that one. So if we're trying to find this one, so probability of z is 0.41, probability of y is 0.35, and then the intersection was 0.17. So if we go ahead and do all that, that would be 0.59 for z union y. And you may say, well, couldn't we just go back through and add up all 3 of these pieces? Yeah, you could do the same thing. You could have gone through and added up all 3 pieces here, because this is anything inside these 2 circles, so you can also add up all 3 of those pieces and get the same answer. All right, so here's what was given up here. And then just using what was given, then here's everything you can go back in and kind of fill in the gaps to get the pieces for what you're going to need. And then they'll start asking questions from that. So they may ask for the probability of z prime with the intersection of y prime. Okay, now, and there's all kinds of different ways you can look at these. So there's not, I know when I was looking through some of this, they showed one way of doing it. I kind of looked at things a little bit different. But if you're talking about the intersection of z prime and y prime, you could think about z prime, which would be everything outside of z. So if you go back to this one, if everything inside the, and here's one other thing we didn't add in, I forgot this one. With everything that's inside these 2 bubbles of z and y, that's 0.59, the whole entire thing has to add up to 1. So to get the number that's on the outside of the 2 bubbles that you have here, outside your 2 circles, we're going to do 1 minus the 0.59, which means that everything outside of those 2 events of z and y, well, that's everything else that's left over, so that would have to be 0.41. Okay, so when you start looking at this one, there's different ways you can kind of go around these. But if it's z prime, that's everything outside of z. So to me, that's one that kind of think about what it would be. If you take out everything that's in circle z, that's going to be the 0.18 that's here and the 0.41 that's here. And if you want to put the total at the end, you can kind of do that one if you want to. But because we're talking about intersection, we're not really worried about this we're going to talk about some other things here. We'll do the same thing for y prime, because we're trying to find out what these 2 things have in common. Well, if this is y, and we cover up what's in y here, And that's going to leave us with 0.24 and 0.41. And since we're looking for what they have in common, there's what they have in common. Because again, when we're talking about the upside down U, that's the intersection. So when these two things cross, we got to tell me what they have in common. Well, then that would be for this one, that would be the 0.41. All right, and again, there's different ways you can do that one, but to me, that's one of those that if you kind of like, if you're a visual kind of person, to me, that's where sometimes just visually looking at it, that would be what we're looking at. So again, if you think about what Z is, if it's everything that's not in Z and everything that's not in Y, then you tell me, all right, if it's the intersection, then tell me what they have in common. So you kind of go with it from there. All right, now somebody's probably thinking, well, what if it was the other way? What if it was not intersection? What if it was union? Well, that's the next question come up here. Okay, so now you could do the same thing on that one. You could kind of set up and do some options on that one. And I think probably the book may kind of take the same approach on this one. But if it's a union problem, you can do this formula right here. That basically we can do the probability of, Z plus the probability of Y and then take out the intersection. So you can kind of visually do that one if you want to, but this is one that you can do it. To me, it was easier to do it mathematically because I was like, oh, hey, we already got everything we need for this one. So we can do that. The formula then would be the P of Z prime plus the probability of Y prime minus, and we're going to take out this intersection of Z prime and Y prime. And we've got all these numbers. If I pull it down just a little bit, we've got Z prime here just from subtracting what was given from 1 back up here. Did the same thing with the Y prime, and we found out what Z prime was here. So we've got all the numbers. We've just got to plug it in that formula. So Z prime was 0.59. Y prime was 0.65. We just found the intersection there, which was 0.41. Work all that out. That should come out to be 0.83. Okay, and then they'll just give you different random parts to find on these. There's no rhyme or reason for any ones that they do. They just throw out different things. This one may be the probability of Z prime union with Y. And anytime they give you one that's a union like this one, they may try to think about like visually going through those, but for one like this, you don't have to visually go through this one. You've got the formula that it's the probability of Z prime plus the probability of Y prime, or just Y, minus the intersection of Z prime and Y. All right, now that one's where we don't have that part yet. So that's the part we'll have to go back and look at it. But we do have Z prime. That was 0.59. We were given the probability of Y, which was 0.35. We've got to find the intersection of Z prime and Y. All right, so let me do that. Let me pull back up to the top so we can see the Venn diagram here. So Z prime and Y. Okay, so again, if we think about what Z prime is, Z prime is everything that's out here, which is 0.41 plus 0.18. And then we're going to intersect that with y, which is just 0.17 and 0.18. Oh, let me slide that up a little bit. Let me do that one again. So z prime is taking everything that's outside of z. So that's the 0.18 and the 0.41. And then we're going to intersect that with y, which is just 0.17 and 0.18. So then what they would have in common then is that 0.18. Okay, so then we can go back to here and get that that was minus the 0.18. And then from there, it's just doing a little bit of math on this one, put all that together, and that would be 0.76. All right, and one more here. All right, and this one's going to be just an intersection, so we don't have to worry about doing the formula or anything on this one. Now, and again, when you're doing the unions on these, you don't necessarily have to do this formula. You can do, other ways of doing that one. But to me, I always try to go back to this formula when I'm doing the unions. Intersections, that one's when you just almost have to do those by hand. All right, so we need the intersection of z and y prime, so we'll do the same thing here. Okay, so we're going back to this one and doing intersection of z and y prime. All right, so z is everything in here, so that's 0.24 and 0.17. Y prime is everything outside of y, 0.24 and 0.41. So what they would have then in common would then be the 0.24. Okay, so with the Venn diagrams, that's kind of your thought process that you want to go through those. And again, there's different ways to get those answers, but for me, with the intersections, to me, that was easier just to use the formulas. If it's this one, it's easier just to go back and start covering up parts so you can kind of see the parts that's there and just write down those parts and pieces. It's to me, it's better. I was always had to put the numbers together, but then I realized, okay, I'm trying to find out what they have in common, so I need to write down each individual piece, and then I can see what it is that they have in common when I go through those. Okay, everybody okay with the Venn diagram on that one? Any thoughts, any questions there? Okay, got some goods there. So, all right. So I think number 4, they'll give you another Venn diagram problem, kind of similar to that one. They may change up some of the wording on that one. For one of the homework questions that they have, just think this is similar to number 5. They go back to this rolling a die type question. But here's where they change it just a little bit. So we're still talking about a single fair die. And they're going to flip on this one. Now we're going to the odds. So now it's not probability. Now it's talking about the odds on this one. They're going to ask, what's the odds in favor of rolling a 1? Well, we know there's 6 possible outcomes. There's basically one way you can get a 1. And there's 5 ways you're not going to get a 1. So it's 1 to 5 on that one. And again, I think sometimes they may also use the word 2 in the middle, but either one of those 2 would be fine. Okay, and that's one where, again, we talk about the odds. That's where you're talking about the probability of the event, and then everything that's not in that event. So there's one way to get a 5, and then there's 5 ways that you can get something other than a 1 for this one. If you're rolling let's say you're rolling a number that's greater than 2. So that could be the 3, 4, 5, or 6. So there's 4 different ways you could win on that one. Numbers that are less than 2 or less than or equal to 2, that would make it. So there would be 2 there. And this is when they are going to ask you that if you write this problem out, they're asking you to simplify it. So it's almost like when you have these, if you have the 2 numbers that you can divide them both by a number, you have to go back and divide them both by, in this case, 2 and make it 2 to 1. So they will ask you to put it in simplest form. Okay. And then pretty much the rest of the section, the back part of the section, is they're going to ask you just different things with, going through the different odds of favor of this one, working with that one. And then I think this is similar to question number 9. They're going to ask you, all right, the probability of getting a degree, and they'll specify. They'll give you some word problem on this one, but it doesn't really matter what it is. But let's say the probability of getting a degree is 39 out of 100. Maybe it's been 100 graduates, 39 of them had a degree in this. What's the probability of getting a degree in this specific field or whatever it's going to be? They may flip right around and ask you, all right, what are the odds of getting that same degree? Well, there's a 39 out of 100 chance, so we know it's going to be 39. And then to get the other number, basically just subtract these 2 numbers. So that's 39 to 61. Okay, so that one, when you see those are really not bad. Switching from odds to probability, it's just, they can flip back around and ask you the same question and say, okay, if the odds are and it doesn't really matter what it is that we're talking about here. If the odds of an event are 4 to 13. What's the probability? Well, it's going to be 4 out of something, because we know that there's 4 ways you can get this thing. And if they ask you then to turn around and put it in probability, now you're just going to take these 2 numbers and add them together. They'll make it 4 out of 17. So switching from odds to degree or degree to odds, really pretty straightforward. You're either taking these 2 numbers and subtracting them to get the second number that's here, or if they give you the odds that's here, you add these 2 numbers together to get to the total that would go underneath the bottom of it there. Okay, and then the last problem I saw out of 8.4 that was any kind of something different. I remember reading this one and it kind of threw me for a loop here. said there was somebody was going in the store. They were picking out 3 types of shoes. And 3 types of shoes to pick from. One was a flat, one was a 2-inch heel, the other was a 3-inch heel, and there were 3 colors. There was black, there was a light brown, and there was a dark brown. And then I think the question asked, okay, you could pick any one of these combinations of things that you could go through. So if you pick the flat, you can have black, light brown, or dark brown. So there was 3 different ways you could pick flats. There was 3 different ways you could pick heel. Same thing. It could be a 2-inch heel with black, light brown, or dark brown. You have a 3-inch heel here that would be with these. So if you go through that one, there's basically 9 different outcomes. 9 different events, 9 different ways you can get all these different pairs of shoes that you're looking at. Because you can do the flat, black, light or dark, 2-inch heel, black, light or dark, 3-inch heel, black, light or dark. So if you go through that one, there's 3 different ways you can go through those. And then they may ask you, if you go through this one, what's the probability of picking a shoe with a heel? Doesn't matter if it's a 2-inch or a 3-inch. Well, there's 9 outcomes. There's 6 different ways you can get shoes with heels on them. So it'd be 6 out of 9. Well, that would be 2/3. Now they could also, again, they could flip around and do what would be the odds, because they may ask for one of those questions the same way. They may ask, what's the odds of picking a shoe with a heel? Well, if you've got this in simplest form, there's 2 different ways we could do this one. And again, the total is 3, so that would have to be a 2-to-1 ratio. Okay, so, and to me, once you went through and started doing a few problems here, it all gets fairly, I think, straightforward. Some problems you have to kind of figure out exactly what it is that they're asking. That's probably the hardest part. But then once you actually start running through the numbers are pretty straightforward when it comes off of it. So. Okay, so what we're going to do, there is section 5, but we'll wait and do section 5 Tuesday, and then we'll do section 5, finish out everything in section 5, and then we'll probably start chapter 9 after that. We'll probably do 9.1, just get a little bit of preview of 9.1 going, and then we'll finish up chapter 9 Thursday of next week. And that way, because we got a little bit more time, we don't have to get in too big a rush on these, so we'll probably wind up doing a couple of sections a day just to make sure we've got anything. So. All right, any questions that y'all have about anything?